Dear students, I welcome you all for the online learning platform for the course Warehousing Automation. So, this video lecture will take us to the next topic in Unit 4 Decision Making Process in Warehouse Automation. So, this video lecture will be discussing about Pareto analysis. So Pareto analysis is the ninth chapter in Unit 4. So Unit 4 can be divided into two broad perspectives. The first thing is overview of decision making, how to design and implement a decision making support systems, then followed by the various core agenda or core objectives of decision making we just discussed, followed by the tools and techniques we have been discussing. So as of now we have discussed three tools, and now the fourth tool what we are going to discuss is Pareto analysis. So what is Pareto analysis, how it works, what will be the nature of outcome it is going to come. So all such things we will be discussing in this particular presentation. Pareto analysis. See, before we get into the topic, we should know one basic understanding that in the world, especially in the quality management system, there are 14 tools are there, 14 assets, there are 14 tools and techniques are there for the case of quality management. And these 14 tools can be broadly classified into two major things. The first thing is new 7 QC tools, quality control tools, and old 7 QC tools. So likewise, this 14 can be classified. So when we see the old 7 QC tools, so one of the tool is Pareto analysis. So there are 7 tools are there in the old regime, there are 7 tools are there, and Pareto analysis is one such tool in that particular old 7 tools. So now we'll see what is Pareto analysis. So basically Pareto analysis is a significant tool which is used for decision making process. So it is going to use an unique rule to perform this. So the unique rule here is Pareto principle, in other terms is also known as 80-20 principle. So the moment you come across Pareto analysis, immediately the concept what should strike your mind is Pareto analysis works on the Pareto principle, also called as 80-20 principle. So now what is this 80-20 principle or 80-20 rule? So here the basic thing is roughly 80% of the outcome result from 20% of the causes. So right now it might be difficult to understand. Don't worry, I've got a set of examples in the upcoming slides. There we can understand how this 80-20 was finalized. Why not it be 18-15 or why not it be 75-25? What exactly was the reason? We'll understand. So who developed the tool, all such things we'll learn in the upcoming slides. So now first, right now what you should understand is there is a tool called as Pareto principle. So it found its place in one of the 7 old QC tools. So this is the basic understanding you should have. The next understanding here is it is a decision making tool used to do when you have got only limited number of data available with you, only hand few of data. Say you have got only 10 data with you. So with this 10 data, how can you come out with? Means the principle which is underlying for this decision making is called as Pareto principle. Also it is known as 80-20 rule. So 80-20 rule, 80% of the outcome is because of the 20% of the causes. So this is the basic understanding you have at this juncture. In the upcoming slides, you can understand why 80-20, how this name Pareto, who invented everything, will come across. First, 80-20. Why 80-20? We'll deal in the next. Now, what is 80-20? We'll understand. A vast majority of problems, 80% of the problems are produced by fundamental causes of 20%. See, in a very simple case, we are facing problem in our car. Okay, 80% of the problem is caused because of 20% of reasons. So this is the simplest understanding. So 80% of negative effect is because of 20% of the car. It need not to be negative, even it can be positive. Okay, even it can be positive, it need not to be negative. So 80% of the problem is due to 20% of the reasons. So this is how you understand at this juncture. In the upcoming examples we can see all other things. So now what is this 80, what is this 20, how to put it in an English term rather than a numerical term, how to put it them in a proper English means vital few versus trivial many. So vital few means, see, vital means important, few important things will be there, and unimportant things will be 80% will be there. So 20% is important and 80% is going to be unimportant, and that unimportant, the term what we use is trivial many. Vital few versus trivial many. So now we'll see how the tool came into existence. In 1940, one of the quality guru by name Joseph M. Juran. So there are quality gurus are there. One among the quality gurus, Joseph M. Juran. So he came out with this concept, and having invented this particular concept, why has he not kept his term as he kept an Italian's name by name Wilfredo Pareto. Okay, Wilfredo Pareto, but it was invented by Joseph M. Juran, but he kept the name of an Italian scientist, economist by name Wilfredo Pareto. Why? Because this Pareto was interested to understand the economy of Italy in such a way that 80% of the Italy, okay, 80% of income in Italy went to 20% of the population. So 80% of the wealth is acquired by 20% of the population. So he just wanted to cross check this, whether 80-20 is applicable only in Italy or other cases. What Pareto did is he went to different countries to understand how it happens, whether 80-20 is predominant or not, whether any phenomenal observations, whether it is going to be an accidental observation. So likewise he wanted to classify, and the shocking facts reveal that 80-20 was true in majority of the cases. So therefore Joseph M. Juran, he also came out with this concept, but as such Italian scientist, he just did the same concept on a massive scale, so he just kept his name. So that's how it got the term Pareto analysis. Okay, students, I hope it might be clear now. So it was invented by one of the quality guru during 1940s by name Joseph M. Juran. So though he had his concept of 80-20 principle, the same was emphasized in a contemporary basis by another economist from Italy by name Wilfredo Pareto. So how he identified was 80% of the income in Italy went to only 20% of the population, and he wanted to justify the 80-20 rule. So he was involving himself for an exhaustive research in this, and the research were also shockingly, it was found to be true. So that's how the 80-20 rule or Pareto principle became a part of Pareto analysis. Now the examples what Wilfredo Pareto he quoted are like this: 80% of service complaints or complaints, customer complaints arise from 20% of your products and services. So he sued a company then. So that's how. So 20% of the products created 80% of the issue. 80% of the delays in the schedule result from 20% of the possible causes of the delay. So again 80-20 delay or 80% delay is due to 20% of the cause. 20% of your products and services account for 80% of the profit. So it was applicable for a company. It did a basic brainstorming work for a company then. 20% of your sales force produces 80% of the company's revenue. 20% of the defects of a system cause 80% of the problem. So likewise in all walks or various walks of the businesses, he involved himself and he affirmed the statement, the principle that 80-20 is quite significant. And that's how even it was understood, or it was found to be right, and later it became part for the Pareto analysis. Now, what is Pareto analysis? How it does the work? Okay, we'll see. So Pareto analysis basically it helps to identify and prioritize the vital few factors that generate the majority of the problems or results in any process. So vital few. So we have got a cluster of solutions or problems that, so from that the vital few has to be chosen, and that is what Pareto analysis does. By focusing efforts on these key causes, companies and organizations can resolve issues efficiently, effectively, and achieve sustainable improvements with minimal efforts. So now a company is having problems. Say there are some 10 problems are there. So when you take out, what Pareto analysis says is 8 problems out of 10, 8 problems are due to 2 causes. Only 2 causes are there. So if those 2 reasons are nicely found and if it is troubleshooted, then these 8 problems will get nullified automatically. So this trivial many problem is because of the vital few causes. So that is what it is going to do. So it is going to analyze the data and it is going to get out the vital few components from the trivial many problems. So steps, we'll see one by one. So the first step involved here is identify and list problems or causes within a process. So first thing is go to the workings part. So you go to the workings part, understand what is happening and list the problems and causes for that particular problem. You have got a problem A, what is the problem for that? What is the cause for that particular problem A, and note it down as cause A. So for problem A, this is what the cause is all about. So likewise, it can be thought of. Then assign a score or frequency to each issue. See, based on occurrences or based on the severity, use some sort of rating factor and let that rating factor be very organic, don't it be impartial, or let it be very transparent and give some score for that, and based on the score we can calculate the 80-20 severity. Rank these causes from the most to least significant. That is, you take the problems, list down the problems on a severity score, you just give a rating for that. The things which are found to be so serious, put it on the top. Those who are not significant, those who are play very poor, least significant, put them at the end. So likewise, you can arrange them in order. Then the fourth step, calculate cumulative percentages and create a Pareto chart. So this is important. So create the cumulative percentage. So it is very obvious that the rating what we give should be in one particular pattern, that the cumulative should not cross 100. So the cumulative should be 100. That's how we are going to give the rating, and we create the Pareto chart. A Pareto chart is a bar graph showing causes from highest to lowest in with frequency with cumulative line overlay. We'll see that in a graphical presentation as an image. Then focus resources on the top causes, typically those covering around 80% of the impact. So this focus has to be there. Whichever accumulates into 80% will be considered. So the key application. So where it is being used means, first it is used in the case of quality management. So initially it found its application in the quality management cases, where for to analyze the sources of defect. See, we manufacture, we produce some 100 components and we find, or we unknowingly or knowingly we have got defects in the process. Okay, so to identify, this particular tool was used on a massive scale. Process optimization targets the major causes for inefficiency. Why the problem or why the process is not 100% efficient? What all are the causes for inefficiency? So when it was analyzed, process optimization for that particular application, it has been chosen. Risk management prioritizes major risks for mitigation. So when you have got problems, so the one which is going to be the severe, we are going to identify. So that's how risk management also it has been used. So now this is where our focus of interest in the context of unit 4, business decision making, allocates resources for maximum effort. So whichever is going to create maximum effect, that will be obviously chosen as the solution. Advantages: pinpoints the root cause with the biggest impact, improves efficiency and resource allocation, facilitates targeted action and prioritization. See, the basic problem to solve any of the causes is to identify the troublemakers. So that's very transparent as far as Pareto analysis is concerned. So it is going to help us to be efficient and improving the resource allocation. It facilitates targeted actions and prioritization. Disadvantages: identifies problem but not provide solution. See, basically it is a tool to analyze the problems, not for the solution. Relies on historical data which may not reflect future condition. See, unlike decision trees or other things where they have the capability for prediction, Pareto analysis is not having such feature. Works mostly with qualitative data, not detailed analysis like averages or variability. So data will always be qualitative. We can't go ahead with quantitative data. So this is one example, one application. So the y-axis shows the count of errors and x-axis represents the sources of errors. So broken links, spelling errors, missing title tag. So likewise other things are there. So a severity rating has been given. So the severity rating, the first broken links is going to be the 1, and the percentage is calculated in the reverse way. And as I told you earlier, the cumulative will be always 100. So therefore Now we divide the 80 percentage line. So 80 percentage above the things which are of 80 percentage is vital few, and below it is going to be trivial many. So once when we solve these three problems, that is broken links, spelling errors and missing title tag, obviously the severity is going to be low and the efficiency is going to be high. Then later on similar activity can be carried out for the rest of the tools and rest of the root causes. Then again the same process goes into. So we knew the concept of continuous KPI. So even such concepts can be, or it is feasible for us to implement using Pareto analysis. So now we are to the end of the presentation. So this presentation took us to a QC tool by name Pareto analysis. Though vastly or widely it is used in a quality control application, but basically it is used even for the case of decision making. So it works on the principle 80-20, also known as Pareto principle. 80% of the 80% of the problems are due to 20% of the causes. How it has been justified? So the inventor was Joseph and Juran. So he named it after the Italian economist by name Wilfredo Pareto. So that's how the tool got its name as Pareto analysis. And the exhaustive analysis, what it did, affirmed the 80-20 rule. So these all are the discussions what we had in this particular topic. Okay. So with this, I just wind up the presentation. Dear students, any doubts, kindly note it down. We shall discuss the same in the online or during offline classes. Okay. Thank you. Thank you for your active learning.